Good morning, students. In today's class, we shall study more about continuous functions, and this time we will focus on continuity of composite functions or algebra of continuous functions. So let's start here with algebra of continuous functions. So here let us consider f and g as two real functions which are continuous at some point x is equal to a of their domain. So what we have here is f and g are continuous functions at some point a. Whenever we refer to functions, we always mean to say real functions. So the sum of two continuous functions is a continuous function. So f plus g is also continuous at the same point x is equal to a. Likewise, difference of two continuous functions is also a continuous function, and this function f minus g is continuous at x is equal to a. F into g is continuous at x is equal to a. F upon g or g upon f is also continuous at x is equal to a. Here obviously function gx is not equal to a constant 0, and 1 upon f or 1 upon g is also a continuous function at the point x is equal to a. So that means we have two continuous functions, so we can have various important results: the sum of two continuous functions, or their difference, the product, or the quotient or reciprocal of the function. Each one of these functions is continuous at the same point x is equal to a. Now some more standard results that we are going to write down here. Certain functions which are continuous in their domains. Which functions are these? These are trigonometric functions: sin x, cos x, tan x, cot x, cosec x, sec x. Modulus function, identity function, log function, the exponential function. All these functions are continuous functions in their domains. We can later on prove one or two results of these, and we'll show them that these are continuous functions. So this is basically standard result. All trigonometric functions, modulus function, this is the identity function, the log function, exponential function. Besides this, polynomial functions, rational functions, all these functions are continuous in their domains. So we basically know now algebra of continuous functions. We know which standard functions are also continuous functions in their domains. And now using these concepts and along with the concept of composite functions, we shall solve some more questions from exercise 5.1. So questions from exercise 5.1. We'll start here with 21st question. Discuss continuity of the following functions. The first part is fx is equal to sin x plus cos x. Now here the question can be solved in two ways. The first method, since sin x is a continuous function in its domain, cos x is also a continuous function in its domain. Therefore, by algebra of continuous functions, the sum of two continuous functions will also be a continuous function in its domain. So here we can directly write down the result, because sine is a continuous function, cos x is also a continuous function. Therefore, the sum or even difference product or the quotient of these functions will also be a continuous function. This is one method. Second method. Now for this function, let us find out the domain, and we know the domain of the function is the set of real numbers. So the domain of the function is the set of real numbers, and if we restrict ourselves to the range, this is the range of the function. So from the domain, let us pick a value a, some arbitrary value a from the domain. Alright, and let us find out here the limit of the function when x tends to a. So this is the function. By direct substitution here, we get sin a plus cos a. For the same question, when you find out here the value of the function at the point a, this is again equal to sin a plus cos a. Therefore, we can say that limit of the function when x tends to a is same as f of a. Therefore, fx is a continuous function. So this is the second method of doing the question. Then next we are moving on to 22nd question. Discuss the continuity of sine, cosecant, secant and cotangent functions. So we are going to take up here sine function, cosine function. So fx is cos x, and we know the domain of the function is the set of real numbers. Let us choose a real number a from its domain. Find out the limit of this function when x tends to a. So by direct substitution, we get cos a. Similarly, value of the function is also cos a. Here, you can once again write down that since the limit of the function when x tends to a is equal to the value of the function, therefore cos x is a continuous function in its domain. Then next, let us try out checking for the cosecant function. So the same question, if we take cosec x function, then we know the domain of the function is set of all real numbers except multiples of pi. So let us choose a value a from this domain and find out the limit of the function when x tends to a. Again, by direct substitution, we get cosec a. Likewise, value of the function is again cosec a. So since the limit of the function when x tends to a is equal to value of the function, therefore the function fx is a continuous function in its domain. So this way you can try out the other parts of the same question. Next we are taking up 23rd question. A function fx is defined as sin x upon x if x is less than 0 and x plus 1 when x is greater than equal to 0. We are finding out here all points of discontinuity. Okay, now all this clearly, when you look at this, you get to know that the domain of this function is the set of all real numbers and it has been defined about the point 0. So here we can take the first case to be a case where x is equal to 0. If x is equal to 0, the limit of the function when x tends to 0, when x is equal to 0, our function is x plus 1. So limit of x plus 1 when x tends to 0 is 1. And the value of the function is also 1. So because limit is same as value of the function, so we can say that the function fx is continuous at the point x is equal to 0. Next, let us take second case, and here let us take a point C which is less than 0. That means we are here in this part of the domain. Now when C is less than 0, in that case, the limit of the function when x tends to C. Let me draw a number line here. This is the point 0. So whenever the function is less than 0, it is defined as sin x upon x, alright? And when it is greater than or equal to 0, the function is defined as x plus 1. I have taken a point less than 0. Suppose this is that point C. So when you are approaching C from the left side or from the right side, the function remains the same. So we are directly finding out the limit of the function, and this is our function. So when x tends to C, the limit of this function is sin C upon C. And then the value of the function at the point C is also sin C upon C. This means the limit is same as value of function. Therefore, the function fx is continuous at all points of x which are less than 0. Then there is a third case, x greater than 0. So let us take a point, say D, which is greater than 0. That means somewhere here. Here again you notice when you approach D from the left side or from the right side, the function remains the same. So we can directly find out here the limit of the function when x tends to D. So our function is greater than 0, function is x plus 1. So by direct substitution we get d plus 1, and likewise value of the function is also d plus 1. Once again, limit is same as value of the function. Therefore we can say that the function fx is continuous at all points which are greater than 0. So see here, at the point 0, function is continuous. At all points less than 0, function is continuous. At all points greater than 0, function is continuous. That means there is no point of discontinuity. There is no point of discontinuity in the domain of the function. So next question is 26th question. Function is defined as k cos x upon pi minus 2x when x is not equal to pi by 2, and the function is equal to 3 when x is equal to pi by 2. We are given that the function is continuous at the point x is equal to pi by 2. Hence we have to find out here value of k. So look at this, x is not equal to pi by 2 means x is either less than, this means x is either less than pi by 2 or x is more than pi by 2. So since for less than pi by 2 and for values more than pi by 2 it is the same function, So we will find out either left hand limit or the right hand limit only. So let us find out here the left hand limit. The left hand limit of the function at the point pi by 2. So here our function is this, k cos x upon pi minus 2x. Here if we directly substitute, we get here the indeterminate form. That means this function has to be simplified. So what simplification is possible? X will tend to say h whenever h will tend to 0. So because we get the indeterminate form here, so let us change the limiting point to h. So here, whenever we change the limiting point to 0, this variable has to get replaced by pi by 2 minus h. So pi minus 2 times pi by 2 minus h. Why minus h? Because we are finding out the LHL. If we were finding out RHL, we would have written pi by 2 plus h. So this can be simplified. Cos pi by 2 minus h is sin h. Simplifying the denominator, pi and pi will get cancelled and we have 2h here. So k is a constant, 2 is a constant. So here we know that whenever the limit of the function sin h upon h when h tends to 0, this value turns out to be 1. So the LHL is coming out to be k by 2. If we find out RHL, that will also be equal to k by 2. So limit has been found. Next, the value of the function at the point pi by 2 is given 3. So value of function is this. Now we are given that this function is continuous at the point x is equal to pi by 2. So that means the limit of the function when x tends to pi by 2 should be equal to the value of the function. Value of function is 3. The limit we have found out is k by 2. Hence we are able to find out the value of the constant, which is 6. So next we'll see question number 30. Function is defined as 5 when x is less than equal to 2. It is ax plus b when x is greater than 2 and less than 10, and it requires value 21 when x is greater than equal to 10. So we are given that this function is a continuous function, and then we have to find out here values of a and b. Now since it is given to be a continuous function, so where is it continuous? It is continuous in its entire domain. You can see the domain is defined about the points 2 and 10. So here are the points 2 and 10. Less than equal to 0 function is 5. In the open interval 2 to 10 function is ax plus b, and for values greater than 10 function is 21. This is how we will see at the domain, and since the domain is defined about the points 2 and 5, so we know function is continuous at 2 and function is continuous at 10. So let's start with this. Since fx is continuous at x is equal to 2, the left hand limit at x equal to 2 should be equal to the right hand limit at x equal to 2. This should be equal to f2. So less than left hand limit means x is less than 2. Less than 2, it is a constant function, so we can directly write down left hand limit is 5. The value of the function at the point 2 is again 5. So what we need to find out here is the right hand limit x greater than 2 defined by this. if we directly write down here, we get a value 2a plus b. So this is one linear equation that we get. I've written here the results directly, first equation. Then secondly, the function is also continuous at x is equal to 10, which again means that the left hand limit at x equal to 10 should be equal to the right hand limit at x equal to 10 should be equal to value of the function. So here again left hand limit, that means x is less than 10. X is less than 10, this is a function. By direct substitution we should get 10a plus b. The right hand limit x greater than 10 is a constant, so that is right hand limit, and the value of function x equal to 10 is also 21. So here we get another linear equation in a and b. Let's call this equation number 2. So now our next step is to solve equations 1 and 2. So let us multiply the first equation by 5. So we get here 10a plus 5b is equal to 25. And from this, let's subtract second equation. So 10a plus b is 21. This is what we are doing here. So when you subtract, you change the signs. This term gets cancelled. 4b is equal to 4, which means b is equal to 1. b is 1. Substitute this value in equation 1. So in equation 1, what do we have? 2a plus b is equal to 5. So 2a is 4 and hence a is equal to 2. So this way we have got values of a and b. The 31st question is defined as cos x square. You can see this is a composite function, hence we can break it into two parts, two elements. Gx is cos x and say hx is h square. Now you know gx, because it's a cos function, this is a continuous function. This is a polynomial function, and we know polynomial function is also continuous. So hx is a continuous function. Now since gx and hx are continuous functions, therefore their composition g of hx, which can be written this way, hx is x square, so this in the function g, the variable is x square. This is also a continuous function. So here we have again used one important result, that if we have a composite function and its component functions are continuous functions, gx is continuous function, hx is a continuous function, then the composition of the functions will also be a continuous function. Next we are doing here the 34th question. 34th question, function is defined as mod x minus x plus 1, and in this question we are finding out all points of discontinuity. All points of discontinuity. This is what we are finding out. Let us write down here fx as gx minus hx. So you can clearly see gx is this function, hx is this function, and we know mod x is a continuous function. Likewise, mod of x plus 1 is also a continuous function, and therefore the difference of two continuous functions will be continuous function. So we get to know that fx is a continuous function. Where is the function continuous? In its domain. So if the function is continuous at each point of its domain, so there is no discontinuity at all. Therefore, there is no point of discontinuity.